A squat jump is a vertical jump and among the most often used tests for the maximal anaerobic power output of the lower extremities. It is a concentric muscle action which involves the coordinated extension of the torso, hips, knees, and ankles. Based on the parameters derived from the ground reaction force and flight time, the dynamics of this elementary movement pattern can be thoroughly studied. According to the goals of the test, specific variations of the measured movement task can be used. Enter the Squat Jump Test module from the main window by clicking on the Squat Jump button. Make sure you have acquired the subject's body weight beforehand. Consistently with the organization of all the MARS test modules, the interface is divided into a left setup panel, a right analysis panel, a bottom measurement panel, and the central signals and results area. Before starting the measurement, appropriate input parameters must be determined in the setup panel. These are lower extremities, where you can choose among the following: bilateral jump, jump with the left leg, or jump with the right leg. And upper extremities, where you can choose among hands positioned on the hips, freely positioned, crossed over the chest, or positioned behind the neck. To start with a measurement, click on the New Measurement button. After launching the test module and clicking New Measurement, initialization and offset takes place. During this time, the subject should not be on the force plate. If necessary, the measurement mode can be cancelled by pressing the Cancel button. Before starting the measurements, the subject has to assume an appropriate initial position, this being knees and hips flexed to 90 degrees, torso leaned slightly forward, and eyes directed to the front. The goal of the task is to produce an explosive vertical jump with no prior eccentric movement. Initiate the measurement by clicking the Start button. When landing, the very first contact has to be performed with extended legs and the feet in plantar flexion. This is then smoothly followed by normal amortization of the lower extremities. The measurement stops automatically after landing. It can also be stopped manually by clicking the Stop button in the lower panel. If the jump was not correct, the jump indicator in the right panel will indicate a wrong jump. The measurement can be repeated by clicking on New Measurement, thus not saving the previous repetition. If you are satisfied with the measurement, you can save it. The central window displays the ground reaction force signal measured by the force plate. Markers are positioned automatically on the most relevant spots used for analysis. The initiation of the push-off action, marked by Start Cursor, is identified by a steep increase in the ground reaction force profile. Takeoff and landing can be easily identified by the moment when the ground reaction force falls to zero and starts to increase again. The cursors positioned on Start, Takeoff, and Landing can be manually adjusted. Other cursors are adjusted automatically. If again automatic positioning is required, click Analyze, and the cursors will be repositioned according to your settings specifications. If the cursors are repositioned, the new analysis can be saved as a new measurement by pressing Save. The data from the analysis can be viewed under the Results Table tab. The results parameters are divided into three main groups. General parameters. These include different velocity, acceleration, force, power, and work parameters. Additionally, various time profiles and force impulse parameters are calculated. A more thorough description of the parameters can be accessed by right-clicking on the parameter name. Options for displaying specific sets of parameters can be accessed under the Parameters View menu in the right panel. For more information on this topic, please refer to Tutorial 7.